Hi, this is Project Spark Alphabet. I'm Lady Lex UK, and today we're doing the letter S. For my prop, I have chosen signpost A, and for my brain tile, I've chosen swimming. So let's start off with our prop tile today. That's signpost A. Now, you might be familiar with this prop. It is one of the few flat objects in Project Spark that can be used as planks of wood. Well, that's what it is really, it's a plank of wood. It's unfortunately rounded off and not symmetrical, but it's best we've got. So let's say you wanted to make something like this. I'm going to make a trough. No, I don't want to rotate it that way, I want to rotate it that way. Okay, so we're gonna just make a rough, let's put some hay in it. Ooh, that's slightly big. There we go. Okay, so I've made a feeder, and you can copy and paste this and put this in your world and have multiple feeders for a farm or whatever. There we go. And let's just go into test mode and have a look at that. See what it looks like. And oh dear God, oh dear, we've forgotten it's a signpost and it's got a brain in it, and this is what's going to happen. Now this happens a lot with people. They forget that an object has a brain in it and they forget to delete it. They make something. Can you imagine you make a whole pirate ship using these as planks, and you get that. What can we do? Well, if you haven't used the signpost for anything else, you can do this. For each of objects, gallery picker, signboard A, it, multi-brain, deactivate brain. So for each of the signboard A's, we're going to turn their brains off. And now we don't have the problem anymore. So if you've made something, it doesn't matter if you glued it or anything, it's going to deactivate the brain in every object that is signpost A. Actually, I haven't tried this, but let's see. This is a signpost A. Let's call it test. And it's got its brain in. Let's see if it makes a difference whether we've renamed it or not. It makes no difference whether we've renamed it or not. It is a signboard. There we go. So as long as you haven't used it in anything else, you can use that brain to deactivate all of the signposts, so you don't have that problem anymore. So if you've got that issue, there is a solution. Okay, let's have a look at the signboard itself and see what it does and how it does it. So here is our signboard, and you can see it puts a message in a box above it, a bit like a character when you walk up to a character and it has something to say. It's doing this. Now I don't think that's very good, because you've got a sign here. We could do with that message being on the sign. So what I'm going to do, I'll give you some code in order to improve this message. So, first things first, it says create message as text box. I don't think we want the text box, so we'll remove that, and we're going to put in without frame instead. So now it's going to put a message in without the frame, but we want it on top of the signpost. So we're going to create a vector variable, and we're going to make it the center socket. And we're going to change this so that its position is at world position of the sign. So it's sign center socket. So now we've got our message on our sign, but it doesn't scale with how close we are. Now you could put some fancy code in to scale the text depending on how far you are away, but I think the best way of solving this simply would be to change the sensor, because it's quite a big sensor. You see it's quite a large area. If we reduce that down, so we'll just pull that down, pull that in like so. Now we've got that message, but we have an extra problem in that, as you can see, because it's on the display layer, it's in front of our player, which isn't ideal. So what we really could do with is that you can read the message if you're standing here, but not if you're standing here. So I would recommend you use in trigger zone instead. And if we go into the brain sensors again, and we have a look at our trigger sensor, there it is here. Let's just move it over to the side and make it a little smaller because it's quite big. There we are. So you have to be standing in that box in order to read it. And just so that our player knows roughly where that is, let's just stick this transparent, scale up a bit, circle in there. And as you can see, it's got a sound effect in there. So we'll take away the sound effect, like so. So now you have to be standing on that black square, and there we go. It reads the message on the sign. And I think that you agree that looks a lot better. You're not, obviously I've got it slightly in the wrong position, so you can still do that, but you know, just move it slightly away, you'll be fine. There we go, create a message. Ideal. Now let's say we wanted that create a message to be at the top of the sign. How would you do that? Right, there's a child line for this. We're just going to move the Y vector slightly. So we're going to add, not very much, it doesn't need to be a very big number. Let's try with 0.3. There we go, that's moved our message to the top of the sign, which I think looks quite good. There you go. That's how to improve the signposts. Right, so we don't need that anymore, we can delete those. Right, let's have a look at the swimming turn. Now, I'm not going to teach you about underwater swimming or anything like that. I have tutorials available in my playlist. Have a look for it if you're interested in underwater swimming. What I'm actually going to show you here, somebody actually asked me about this, is how can you detect if an object is underwater? And it is not as simple as you might suspect. You can tell when an object is swimming, and I say object, let me just show you what I mean. So here is our player, and I've got in here, when swimming, hologram. So he's going to turn into a hologram once he's swimming. So we'll dive into the water. There we go. So we're swimming in the water. He is a hologram, and as soon as he walks out and he's no longer swimming, he's not a hologram anymore. So that swimming detection is detecting whether or not his swimming animation is on or not. And the swimming animation is not set off as soon as he enters the water. So you can have him in the water, look, quite far. I mean, you can get up to his waist, look. No problem, he's not swimming. He gets to chest height, there we go, and he starts to swim. Right, so a character like this will need to be at least up to his chest before it will detect that he is swimming. So you could use that, because pretty much a water level higher than that, he's going to be pretty much underwater. So you could use swimming as a detector, but there are some issues with it. Let's put some hay in here. Now, this hay bale is a fixed object. There we go. And we'll put our swimming hologram brain in there so we know when it's swimming. So it's in the water, it's halfway in. So that should be enough to set off that sensor. Except it's done absolutely nothing, because a fixed object doesn't have swimming animation, so the swimming animation doesn't kick in, so it doesn't detect that it's swimming. But it doesn't actually need to play a swimming animation for it to work, so we change the physics to character. And voila, it recognises the fact it's swimming. In fact, it just needs to be touching water as an object. This particular object just needs to touch the water and it will be detected as swimming. So you can do it with a character, but no other type. So a tumbling object or a fixed object will not count. The swimming will not work. So how else are we going to detect whether it's in the water or out of the water? Well, it's difficult, shall I say. Let's imagine you've got this in the water. Let's put it on the land. Okay. So what you would have to do is you would have to work out the different water levels for this object. Let me just change his physics back to fixed. There we go. This fixed object. So in order to determine whether or not it's in water or underwater will depend on the water level number. So we'll put some code in here that's going to increase that water level. Sorry, water level increment by 0.01. Okay, and we'll display the world water level at the top of the screen. So as the world water level comes up, okay, 9.8, 9.8 it hit that hay bale, and 11 it's underwater. Okay, it's quite fast, so you got to check. You could set that to a much slower pace so that you can get a really accurate number. So let's do some code in here. So when world water level is greater than, what did we say, 10.3, wasn't it? 10.3. When the world water level is greater than 10.3, then we're going to set a boolean. Not for underwater, we're going to set a boolean that says in water. So when in water, we're going to, what should we do? Well, we'll make it a hologram so it makes it nice and easy. Okay, so when in the water level is greater than 2.3, it's in the water, and we're going to make it a hologram. There we go. So there we are. Boom. There we go. and we can do something else when the world water level is greater than 11. We're going to change its color. Let's change its color. Let's make it black. So solid color equals black. There we go. So obviously you can set anything you like. So whatever you want your object to do, you could have it so that it's destroyed if it's underwater. As soon as it's in the water, it does something, it floats about. You know, all sorts of things you can do. And because we send it to a hologram, you can't see that it's black. Okay, so let's turn that one off because we can't see it doing it. Hang on then. Here we go. So, boom! It's black now because it's underwater. There we go. Our water level is continuing to rise, and of course our player is swimming, so he's a hologram. There you go. So that's what you can use swimming for, but it's not as good as the world water level detection for determining whether an object is underwater or in water or what level of water it is on, because a fixed object and a tumbling object does not work with the swimming tile. Okay, so thanks for watching. Hope that's been useful to you, and as always, keep sparking.